Previous video we learned how to convert exponents, alright, and sort of express them into the logarithmic form. Into their logarithms. And let me give an example. We may have said 4 to the power 3 is 64. How are we going to re-express this? We instead rewrote it as the logarithm of the base 4 that gives me 64 is 3, and that's how we did it. Now I'm going to ask you, and in this video what we're going to do is learn how to express the logarithm if initially given to us, and how to express it as the exponent form. So if I gave you log to the base 3 of 9 is equals to 2, how would you write this as an exponent? And that's the question we're going to be dealing with today. So let me take this example down here and continue with this log base 3 of 9. Log base 3 of 9, that gives me 2. Well, remember, 2 is the power. This is our power, or the index, or the logarithm, right? Or our logarithm. Alright? So basically, 2 is a number which I raise my base 3 to, right? This is the base, remember that. So if I raise 3 to this power 2, I get the result, which is 9. Okay? And let's try to work that out with one other example a little lower here. Let's say I gave you log to the base 5 of 125 is equals to 3. Okay, well, remember 3 is our power, so 5, right, to the power 3 is 125, because remember 3 is the power and 5 is the base, and 125 is our result. And so let's give it a general way of saying it. Let's see if we can come up with a general way of saying it now all of a sudden. So let's say I had a to the power b is equals to c. How am I going to express this? Well, that's simple. Log to my base, which is a, okay, which gives me c equals to b. And all you got to do is just plug in the values in their right places. Okay? Just plug them in their right places. I'm going to draw 2 arrows, 2 half arrows. You can always express them in both ways. Where remember, a is our base in both cases, c is the result in both cases, and b is the logarithm or the power. Okay, let's try and work out on what I want to think of as special kinds of logarithms. Let's start off with this one, which is log to the base 3 of 1 is a certain value. What is the certain value? Well, let's stop and think about it. Let's try and express it. Let's rewrite this and say maybe log to the base 3 of 1 is x. Solve for x. Well, the first thing I want to do is express it in our exponent form, which would be 3 to the power x is 1, right? And I got to think about it. What number do I raise 3 to give me 1? That should be 0, because 3 to the power 0 is 1. And this is true for every number. Any number to the power 0 is 1, as we learned in our indices. So if I wrote this question differently and said maybe log to the 4 of 1 is equals to x, well, 4 to the power x is 1, 4 to the power 0 is 1. And I can say the same thing about 5 to the power 0, or 6 to the power 0, or even 100,000, or whatever the number is, 1 million, whatever I'm writing. To the power 0 will always equals to 1 based on our indices, right? So I hope you understand why log to the base 3 of 1 is 0. And this is usually regarded as a special kind of logarithm. I think it's because 0 is involved or something of the sort. And let's think about this other one here. Let's try and solve a question like this, where I said log to the base 3 of x is 2. Okay? Now, as always, I have a missing value here, and I know I can express it again in the exponent form, and that's what I want to first do. I want to first express it in the exponent form, where I know 3, right, to my logarithm, which is 2, 3 squared, right, gives me the result of x. Solve for x. And I know 3 squared is 9, therefore 9 is equals to x, or x equals to 9. Same thing. I hope you understood what I did there. And if you want to do something more intuitive, you can think about it as 2 is the power you raise to 3 to give you x, right? So what should x be? If I raise 3 to the power 2 and get x, that means 3 squared is x, and that's the kind of reasoning that gets you to using the exponent form. That's the kind of reasoning that gets you to the exponent form. Let's try another example very similar to this one. Let's try something just to get the hang of it. If I gave you log to the base, let's say 4 of x is equals to 1. Now this is interesting. Let's have a look at it. Well, basically what I'm saying is 4 to the power 1 is x. Therefore 4 equals x. Alright? And I hope this video made sense to you, and you're completely fine with the basics of logarithms. Oh wait, before we go, let's try one extra little interesting one I personally like. Let's say I gave you log to the base 9 of 3. And this is equals to x, and they say solve for x. Well, I know, again, 9 to the power x is equals to 3. And to this point, you've always been dealing with the base being the lower number than the result, right? Here in this case, sorry, let's go up a little bit. For example, here, your x is 9, but the base, which is 3, was less. In this case, well, you kind of get my point. And in this case, you got a bigger base and a smaller result. What could your answer possibly be? Well, I know 3 is the square root of 9. 3 is the square root of 9. And how can I express the square root of 9? Well, 9 to the power half is equals to 3. Does that not imply that 9 to the power half is equals to 9 to the x? It absolutely does, right? And that must mean that 9 to the power half is 9 to the power x, right? So surely half must be equals to x. A half must be equals to x. Let's try another interesting one, just something very similar like this. I gave you log to the base 5, or rather to the base 125, which gives me 5, and I ask you solve for my x. Well, I know 125 to the power x is equals to 5, right? And I also know in my mind that 5 cubed is 125. 5 cubed is 125. Therefore, 125. Therefore 5 is the cube root. Cube root, right? So if I wrote 125 to the power 1 over 3, that should give me 5, right? But therefore 125 to the power 1 over 3 is exactly the same thing as 125 to this power x we're looking for, right? Is the same thing. And just like in the previous example, 1 over 3 is equals to x. I hope this video has made sense, and I hope you keep watching a couple more. Thank you.